So let's look at our projectile motion lab and let's talk about that particular item. So if I have a tabletop, and I'm going to measure the height of this tabletop, and I'm going to go ahead and use this as 1.2 meters. Now we said that we're going to use our video analysis data where we're going to use a piece of tape and we're going to take our picture and we're going to say that that is 0.10 meters and our ball is going to roll across here and we're going to measure the time that it takes to travel 1.0 meters. And let's say that that time, for grins and giggles, we're going to say that that time is equal to 0.7, no, I want it to be 0.07 seconds. So I can calculate the velocity because my velocity is my change in position over my change in time. So I'm going to have my 0.1 meters divided by my 0.07 seconds. And if I do that, it's going to be going at 1.43 meters per second. Now I want to do this 5 times, okay? So if I do this 5 times, let's say I end up with 1.50 meters per second, and I end up with 1.40 meters per second, and I end up with 1.36 meters per second, and I end up with, we'll make this 1.44 meters per second. I'm going to look at my maximum velocity. My maximum velocity is 1.50 meters per second. My minimum velocity is 1.36 meters per second. And my average is we're going to add all of those up. So I'm going to plug those into my calculator. 1.43 plus 1.5 plus 1.4 plus 1.36 plus 1.44. And I'm going to divide that by 5. And my average ends up being 1.426 or approximately 1.43 meters per second. So I've got a maximum, I have an average, and I have a minimum. So my velocity actually has an error. If I look at this, my velocity actually has an error. And if I look at the difference between my 1.5 minus my 1.36, this actually has an error of plus or minus 0.14 meters per second. So I can actually start doing an error analysis. So that's kind of all well and good. So now we're going to look at our situation. We've got my ball that's coming off. It only has a velocity in the x direction, and we're going to use that average velocity in the x direction. My average velocity is 1.43 meters per second. And we know this is my initial velocity in the x direction, and my initial velocity in the y direction is 0 meters per second. But we know what's going to happen as this interacts with gravity. It's going to fall off the edge of the table, and we're trying to calculate our target distance. Well, to calculate this distance, we know that that distance is going to be my initial velocity in the x direction times time, but we don't know time. We don't have a good value of time, but we can get that because it doesn't matter anywhere I am on this curve. And this is where we start talking about our vectors. All right. Anywhere we are on this curve, I'm always going to have a Vx component, and now I have a Vy component. But now I've got, if I'm looking over here, this is my vector tangent, right? But here's my Vx, and here's my Vy. I can add that Vx and I can add that Vy because we have independent motion in the X and Y directions. Think of our train picture that we had last week, where we were looking at the train. I could be jumping up and down on the train all the time, and it looks like I'm just going up and down. But we know the train is progressing down the track. So I'm moving both in the X and Y direction. That's exactly what's happening here. We're moving both in the X and Y direction. So my Y is going to equal my initial time in the Y direction minus 1/2 my acceleration due to gravity times time squared. That's going downward because we're using that as down and down as negative. Well, I know Y, I know G, I can solve for T. T is going to equal 2Y divided by G and the square root. So this is going to be 2 times 1.2 meters divided by 9.81 meters per second squared. So underneath the square root, I've got second squared. So, and when I do the calculation, I get 0.049 seconds. So now I have time. So if I know my D and I know my initial velocity is 1.43 meters per second, and I know my time is 0.49 seconds, I can calculate my distance. And my ball should end up at 0.71 meters away from the end of the table. This is very similar to the example that you have in your book. You have an example in your book that's very similar to this, where I have an airplane. And my airplane is wanting to drop the package so that the survivors can get the package. So that's the example that you have in your textbook. So this is exactly how the lab is going to flow. And then you have that example in the textbook. All right.